Okay, let's look at what we have for test 4. So the first one is to figure out what that is. Okay, now you cannot divide this 2 to something that's inside there. That's the first thing to see. And you need to get that negative sign outside. So that's how we write that. And now that's equal to 2. And now you can split it up. So that's the answer we should get for that one. Okay. All right, so moving on. All right, there's nothing in front here, so we can drop these parentheses. But now we have to distribute this negative sign to every term. And so that's going to become plus 2i. And those two together give me negative 6. And then I have 6i plus 2i, and I'll get 8i. Okay, so that's my answer. Okay, so looking at the next question. Okay, so let's move on to the next one. Okay, so here we've got that. So we're going to have negative 40 plus 40i. And then we're going to have minus 15i. And then we're going to have 3 times 5 is 15. And we're going to have I times I. Now, I squared is equal to negative 1. So we're going to get negative 40. And then that one's going to give me 25i. Okay. And then I'm going to have 15 times negative 1. And then I put these together, and I'm going to get negative 55 and plus 25i. Okay. Okay. All right, let's look at the next one. Okay. If I'm going to FOIL this, I get 15 minus 18i. And then I'm going to have plus 20i. And then minus 24. Okay, negative 4 times negative 6 is negative 24, and then times I squared. Now, the number inside there, that's equal to negative 1. So I'm going to have 15 plus 2i, and then negative 24 times negative 1. And when I add these two together, I'm going to get 39. So that's my answer for that one. Okay, now the next one, we're going to have this. Okay, so this is going to be 3 minus 4i times 3 minus 4i. Okay. And then I'm going to have plus, and I'm going to have 24 plus 12i, minus 20i. Then I'm going to have minus 10, then times I squared. Okay. And so this is going to be equal to negative 1. Okay, so let's come back here. Let's FOIL this. I'm going to have 9 minus 12i minus 12i. So that's going to give me minus 24i. And then I'm going to have negative 4 times negative 4 is 16, and I squared. Okay. All right. So I'm going to have plus 24. And here I'm going to have negative 8i. And here I'm going to have negative 10 times negative 1, which is going to give me positive 10. Okay. So I'm going to have that, and that gives me 34. And then 34 and 9 is going to give me 43. Okay. And then I'm going to have minus 24i minus 8i is going to give me minus 32i. And then 16 times I squared is going to be 16 times negative 1. Okay. And 43 minus 16 is 27. And minus 32i. So that's what we're looking for that one. Okay. Okay, now let's look at this next one, to find the zeros. Okay, we could look at the graph, but if you see all of these selections here, negative 1 has to be a 0. So from the selections, negative 1 is a 0. So I'm going to put negative 1 up here in the box and do synthetic division, and I should get a 0 over here. Okay, so 1 times negative 1 is negative 1. And when I add, I get a 1 there. Okay, I was reading it wrong. I was thinking there was a comma after that, but it has degree 2. Oops. So, yeah. Let's try that again. There's going to be 2 zeros. Now, I could try and factor it, but 2 numbers that multiply together to give me 8, but at the same time add up together to give me 2, I can't find them. So I'm going to have to use a quadratic formula, and I'll be able to find the zeros. So A is equal to 1, B is equal to 2, and C is equal to 8. So the zeros are going to be negative B plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. Okay. And 4 minus 32 is going to give me negative 28. Don't go starting dividing by 2 because you cannot divide the 2 by something inside there. Now, I'm going to try and simplify that. 28 is not a perfect square, but 28 is equal to 4 times 7. So the square root of 28 is equal to the square root of 4 times the square root of 7, which is going to be 2 times the square root of 7. So I'm going to come back here and replace that with 2 times the square root of 7. And now I can split this up. And now we can see the 2's cancel, so I'm going to get negative 1. and the 2's cancel here, and I'm going to have that. So -1 minus 7 square root of 7i, and -1 plus the square root of 7i. Okay, that's going to be this one here. Okay, now we want to simplify I to the 27. Okay. All right, so I'm going to rewrite I to the 27 as I to the 26 times I. Because if I multiply those together, I get I to the power of 26 plus 1, which is 27. And now 26 divided by 2 is 13. So I'm going to rewrite this as I to the power of 2 times 13. And now with the exponent rules, that's the same as I squared, all to the 13th power. Okay. Now I squared is equal to -1. If the power is odd, the negative sign stays. So I get -1 times I, which is going to be -I. Okay. All right, now let's do this next one. Okay, that's going to be equal to I to the power of the exponent in the numerator minus the exponent in the denominator. Okay, so I'm going to have I to the -19. Okay, so let's see, first of all, what is I to the 19th? That's going to be equal to, well, I'm going to rewrite it like this. And 18 is 2 times 9. So I can rewrite it like that. And I'm going to have -1 to the 9 times I. And the power's odd, so the negative sign stays. And I get -I. Okay. So, so in summary, what do we have? I to the 19th is equal to -I. Now, we want I to the -19th. Okay. But using the negative exponent rule, that's the same as 1 over I to the positive 19th. So that's going to be 1 over, but I just found that to be -I. And now I'm going to multiply top and bottom of this by 1, or I'm going to multiply this by 1, and I'm going to write 1 as I over I. Okay. So I'm going to get I in the top. And what am I going to get in the bottom? Well, I'm going to get I times I, which is -1, and then I take the negative of that, so I'll get +1. So this is equal to I, which is equal to what we were asked for in the beginning. Okay, so I'm going to get I. Okay, now we need to solve that inequality and write the answer using interval notation. Okay, so let's get this back on. Okay. Okay. I need to distribute the -3 through. So I'm going to have -3x minus 30. Now I need to have this side to be 0. So I'm going to subtract 4x from both sides, and I'm going to subtract 14 from both sides. And subtracting does not change the arrow. So I'm going to have x squared minus 7x and minus 44 is greater than or equal to 0. Now I can factor this. 44 is 11 times 4, and so this should factor as negative 11 and plus 4. Okay. Now, what are the zeros of this? Well, positive 11 is a 0, and negative 4 is a 0. So they are X-intercepts. So the graph of this looks like something like that. Negative 4 and positive 11. And it wants to know, where is it greater than or equal to 0? That is, where is it on or above the x-axis? And we can see it's on at negative 4 and 11, and it's above there. And so where is this pink with respect to the x-axis? Well, if I come in from negative infinity, I go all the way up to, and I include negative 4. And then I have a gap, and then I pick it up again at 11, and then it keeps going forever. Okay, so that's what I'm looking for with that one. You could have actually also, once you got it into that form, you could have put it in your calculator. So x squared minus 7x minus 44. X squared minus 7x minus 44. Okay, I'm actually going to have to increase my window to see it. Okay. So the symbol is asking you, where is it on or above the x-axis? And we get the picture that I drew down here. Okay, so it's on or above on the pink. And where is that on the x-axis when you're putting it in interval form? When your x values are between and up to, including negative 4. And then it's on at 11, and then it'll always be above when 11 is greater than 0. So what we want to put into here, it said put INF. So I want negative infinity, then to negative 4. Then I must have a square bracket, then capital U, and then 11 to infinity. So that's what we want for that one. Okay. Same thing here. Okay. So that one is, I'm going to distribute the 4 through, and I need to get 0 on the right. So I'm going to subtract 16 on both sides, and then I'm going to add 3x to both sides. Then I'm going to have x squared plus 7x minus 60. That's what it looks like there. 44 and 16 is 60. Okay. And you might want to see, does it factor? I mean, what you can have 6 and 10 would give us that. Okay, so I could have positive 10 and negative 6, but that's not going to add up to give me 7. I also could have 12 and 5. So positive 12 and negative 5 could do that for me. Now, what are the zeros? The zeros are going to be negative 12 and 5. So those are going to be our X-intercepts. So this is going to look like, since it's positive x squared, it's a parabola that will open up. So it's going to look like something like that. Okay. Now, that means where is the graph strictly below? So not on, but where is it below the x-axis? Since it's just strictly greater than. So it's below the x-axis here. So I don't include these endpoints. Now, where does this happen? Use the x-axis to describe where this happens. So it's below the x-axis when x is between negative 12 and 5. But we just want the interval, and it's an open interval. All right, this will be a parabola opening up because it's positive x squared. Okay, now what are the x-intercepts? Okay, well, we need to get the zeros. And let's see if we can factor that. That's 7 times 11. And so if I have negative 11 and positive 7, that should give me what I want. So what are the zeros? The zeros are 11 and negative 7. These are real zeros, and so those are my x-intercepts. And so my x-intercepts are going to be negative 7, 0, and 11, 0. Okay. So I had to give the one with the smaller x value first. Now, what is the y-intercept? Well, for the y-intercept, you evaluate f at 0. So for the y-intercept, that's found at f evaluated at 0. So everywhere there's an x, you replace it with 0. And so those are just 0. And so my y-intercept is at negative 77. And that's going to be the point 0, comma, negative 77. Now what about the vertex? Okay, well, the vertex of this, a is equal to 1, b is equal to negative 4. Okay, so the vertex, the x-coordinate is going to be minus b over 2a. So the x-coordinate of my vertex is going to be minus negative 4 over 2 times 1, which is going to be 4 over 2, which is 2. So that's the x-coordinate of my vertex. The y-coordinate is going to be f evaluated at 2. So I go back up in here and I plug 2 in. So I'm going to have 4 minus 8, which is negative 4, and minus 77, which should be giving me negative 81. So that's what I think it is. And the vertex is going to be a minimum. because, so I'm just going to write them in. It's going to look something like that, and that's the vertex. And then my y-intercepts are going to be at -7 and 11. Okay, so we can see the vertex there's a minimum. So let's have a look if I put that in. So if I have x squared minus 4x minus 77. Now, with my window, I'm going to have to take that to about -85 to see everything. Oops. Okay, let me try that again. Oh, yeah. That should be -85. That should be 10. Okay. I'll probably be able to see everything now. Okay. So that's what's going on with our function. Okay. All right, same question on this one. Okay, so well, first we need to get this into standard form. So I'm going to expand that. So 11x plus 11x is 22x, and 11 times 11 is 121. Okay, so then plus 22x and 121 minus 196 is minus 75. Okay, this is positive x squared, so it's going to open up. It has end behavior up, up. Positive number times x to an even power. It's going to be a parabola opening up. Okay, so what are the x-intercepts? Well, let's find the zeros. 75 is 25 times 3, so I'm going to need positive 25 and -3 should do it. Okay, so what will make this 0? What are the zeros? The zeros are going to be -25 and 3. And so those are real numbers, and so those are going to be my x-intercepts. Now, the smaller number first. The negative number is the smaller number. And those are my x-intercepts. Okay. 3 and 0. Okay. Now, what about the y-intercept? The y-intercept, you just evaluate f at 0. So for the y-intercept, I evaluate f at 0. And those terms go away, and I just have -75 left. So my y-intercept is going to be the point 0, -75. Okay, now what about the vertex? Okay. That's not what I want. I want that. Okay. Let me write it again. So in standard form, we have that. Okay. The x-coordinate of the vertex. So A is 1, B is 22. The x-coordinate of the vertex is going to be minus b over 2a, which is going to be minus 22 over 2, which is minus 11. So that's the x-coordinate of my vertex. The y-coordinate of my vertex is going to be f evaluated at the x-coordinate. And I'm going to plug negative 11 in there. Okay, so I'm going to put that in my calculator. And I'm going to have negative 11 all squared plus 22 times 11 and minus 75. So 288. So that's my x-coordinate and my y-coordinate. So my vertex is going to be negative 11, 288. And again, the vertex is going to be a minimum because what's this thing going to look like? It's x squared, so it opens up. The x-intercepts are at negative 25 and at 3. And my y-intercept is at negative 75. And my vertex is going to be at negative 11, 288. See. Okay, I was supposed to put negative 11 in there. That's not going to be right. Let's try that again. Negative 11 squared plus 22 times negative 11 minus 75. Okay. All right, negative 196. Okay. So I need to come back here and put negative 196. But we can also see from the picture I drew that the vertex is going to be a minimum. Okay. All right. Okay, this is one where you need to substitute, like was shown in the exercise in the lab and on web work. So let u equal x squared. Then u squared is equal to x to the 4th. And so I can rewrite this minus 18. That's going to become u squared plus 7 times u minus 18. And I can write this now as u plus 9 times u minus 2. And we can see here what will make this 0. Well, I'll have a 0 if u is negative 9. We'll make it 0. And if u is equal to 2. But I have to solve this for x. So if u is equal to negative 9, then that means x squared is equal to negative 9, because that's what we let u be. And if I take square roots of both sides, I'm going to get x is plus or minus the square root of negative 9, which is going to be 3i. Okay. And here we have u is equal to 2. That means x squared is equal to 2. If I take square roots of both sides, I'm going to get plus or minus square root of 2. So I'm going to have minus square root of 2 plus square root of 2, and then minus 3i and 3i. Those are going to be my zeros. Okay. Those are my zeros. Now, what about x-intercepts? You only get x-intercepts at real zeros. So I'm going to have an x-intercept here because the negative square root of 2 is a real number. And I'll have an x-intercept there because square root of 2 is a real number. But these will not yield any x-intercepts because only real zeros give me x-intercepts. Okay, so let's look. All right, this one's wrong because you don't get, your x-intercepts can only be real numbers. Okay. This looks to be the right one here. Okay. All right, same kind of thing here. What you have to notice about that one is that they have an x in common. So I can factor it out. And we use the same trick. We let u. Now, straight away, you should be able to see that 0 is a 0. What is a 0? It's a number where if you plug it in, the whole thing becomes 0. So I'm going to have 0 times that, and it doesn't matter what that is. It becomes 0. So 0 is a 0. And let's see if we can get the zeros of that. Let's let u be equal to x squared. And u squared is equal to x to the 4th. And so I can rewrite this as u squared plus 10u plus 9. That will factor as u plus 9 times u plus 10, u plus 1, my bad. And the zeros of this are u is equal to negative 9 and u is equal to negative 1. Now, what does that mean x is? X squared is negative 9. So if I take square roots of both sides, I'm going to have that here. X squared is going to be negative 1, which means x is plus or minus I. Now, what are all the zeros? All the zeros of f, well, 0 is a 0. And then I have minus 3i, positive 3i, negative I, and I. Now, what about the x-intercepts? You only get x-intercepts at real zeros. So this 0 will yield an x-intercept. These don't. These are not real numbers. So that's what I'm looking for. And that's matching up with this one here. Okay.